Welcome to the presentation of EOSC Perf platform, place to compare computing resources provided for the European Open Science Cloud. The platform is being partially developed in the framework of the EOSC Synergy project. EOSC Synergy project aims to expand the capacity and capabilities of the European Open Science Cloud, EOSC, by leveraging investments and existing experiences, know-how and resources of national publicly funded digital infrastructures in a coherent way. Among expanding the capacity and building EOSC capabilities, the project also fosters EOSC service integration and promotes software and service quality. Thematic services in astrophysics, biomedicine, Earth observation, and environmental studies were selected to validate the service integration solutions. 8 European countries participate in the project. The expected impact is a measurable increase in the number of resources, services, and data repositories offered through the European Open Science Cloud. Since there are more and more computing resources offered, it is in the general interest of users and service providers to compare them all. Example user stories for comparing computing resources are then: a user wants to expand his or her current resources by running the software on other available sites. But how to compare them? He or she, therefore, asks for well-structured and searchable information with the performance numbers. A resource provider uses certain benchmarks to monitor the performance of his or her computing resource. In order to increase the visibility of the site, it could be useful to publish the results of benchmarks. But what platform to use? If such a platform exists, someone may have developed or used a new benchmark and wants to share it, wants to run on various sites and publish results. But how to add a new benchmark tool to the platform? And now Christophe presents what we have worked on to answer these questions.
Our solution to these problems is EOSC Perf. EOSC Perf is a search and compare platform where users can upload and search through results from benchmarks. By comparing the data acquired from benchmarks, users can decide which EOSC server provider would give them the best performance. If the system does not have data for the sites they want to compare, they can also submit new entries. Through a capable search system, users can navigate through results and filter them by data about the runs, but also by data from within the runs. So you can search by the name of the benchmark, the virtual machine provider or user-submitted tags, but also data inherent to the result, like the number of reported CPU cores or the benchmark score. Once the user has filtered down the list of results to a more manageable amount, they can visually compare them using various types of diagrams. For example, users could plot the result on a line graph using a linear or logarithmic scale to visualize the performance per core of each CPU or the speed up from adding more processing cores in specific types of tasks. Currently, only line graphs are supported, but the system is extensible, so this can be expanded in the future. Now for how the app is designed. The internal structure of the application is fairly standard. The web app itself is written in Python 3 using Flask. It handles communication between the front end that the users use and the database. It will fetch or search data on request, but also, if the user is allowed to do so, take in new data, validate it, and add it to the database. Users uploading data must be logged in, so the application authenticates users using EGI check-in and may grant the user extra administrative permissions based on their entitlements. The web app communicates with the model, which contains both the database and the tools necessary to interact with it. It makes use of an extension of Flask that allows us to easily integrate an object relational mapper named SQL Alchemy. What this does is abstract away direct commands to the database engines to fetch or update data, and instead provides us the data structures we want to use as normal-looking Python data classes. This not only makes development faster and easier, since we don't have to write a lot of SQL commands, but also allows the application itself to be database engine agnostic. For development, SQLite was used, but the application could be set up with minimal changes to use other popular engines like MySQL or PostgreSQL. Lastly, the user interface is mainly written using vanilla JavaScript, with some occasional jQuery for things like AJAX calls to submit and fetch data inline. The visual design and theming is done using Bootstrap, which allows for quick development of a modern-looking interface that will both look good and be usable on both bigger and smaller screens. So, how does the application look like and how do you use it? Here's a short summary of what will be in this demo. You can also try it out yourself using the link below, which you can also get by scanning this QR code. When you first open the website, you land on the benchmark search page, since you need to choose the benchmark you want to compare the results from. Here you may search for benchmarks using keywords from their Docker image names or their description. For purposes of demonstration, the application already ships with results from a specific benchmark to allow users to try out the system even if they don't have any data. For the purposes of this demo, we will use this data. When clicking on a benchmark, you are brought to the results search. Starting from the top, we see the benchmark we just selected. Underneath is the filtering section where users may enter search criteria. Your filtering options are site names, user-created tags, or a more advanced JSON filter. To use this filter, select the filter mode, select what value the result should match, and then when you submit the search, the table will be updated with matching results. The JSON filter is a little more advanced, since it compares based on raw data. Results are submitted in JSON format, so we have a syntax to fetch data from a specific location in the JSON. To demonstrate this, let's filter out results with fewer than 4 CPU cores. By inspecting the JSON data, we find the number of CPU cores is stored on the machine, CPU, then count. We enter this into the field and set it to greater or equals 4. If you want to see more data than the standard suggested fields, you may navigate to the column selection screen where you can add new columns based on JSON value paths. An example here would be machine CPU brand_raw, which for this benchmark carries a human readable name for the CPU. Once we've made our choice of good filters, we can compare our results. Let's say we just want to start by comparing results from all available sites. We can simply select all of the results, select the line graph in the diagram section, and we get a diagram. The diagram will of course only make sense once you choose proper axis sources. So let's make a graph where x is the number of cores and y is the time it took. Now, in simple mode, it will just display one column for every result selected. To compare the results better, we'll want to select the logarithmic scale, and since we are comparing multiple sites, we'll enable the option to group the results by site. From this diagram, we can now determine that the benchmark scales pretty well with the CPU count, and that for the best performance, we would pick a 32-core virtual machine on NCG Ingrid. Now, all you've seen thus far is available to any person visiting the website. However, to have full access to the application, you need to log in. If you now try to submit a result, it instead redirects you to EGI Check-in. Here you may log in using your platform of choice, which in my case would be the KIT, and once you've done this, you have access to the full platform. To add a new result, start by running a benchmark. To do this, you can go to the Infrastructure Manager, deploy a machine using an image you can run Docker on, and run your benchmark. Benchmarks are generally expected to output their result data to a file, so you can get the data by SSH copy. Once you have the data, return to the EOSC Perf website and go to the result submission page. Select all the correct data for your result, like the name of the Docker image, the result data, the site it was run on, the name of the virtual machine flavor if you know it, otherwise leave it at unknown, and optionally some tags. Let's say our benchmark is a CPU-heavy benchmark. If there's no such tag, we can easily add one by submitting it in this field, and then we can select it. Finally, once you press upload, the result will be immediately visible to others. You can now submit a benchmark by going to the submit page. Benchmarks are packed in Docker images, so that in theory they can run on any machine capable of running Docker. As a result of this, benchmarks are identified by the name of their Docker image, which goes in the first field. You then may add an optional description, ideally a short one, for the search page. Note that the benchmark search also scans the description, so you can put extra keywords in here. Lastly, you may have a template for your benchmark results, which lists required and interesting fields. For more information about this template, you may go to the benchmark guidelines page that you find here. Finally, submit your benchmark and wait for an administrator to approve it. Logged in users can also report results if they believe them to be inaccurate or otherwise falsified. You can do this by pressing the report button on the result and then describing the issue in the form that comes up. In this case, you may have noticed that the result score, which is the time it takes in seconds, is far too low to be realistic. Finally, for administrator features. As previously mentioned, administrators have to approve new sites and benchmarks through the report interface. You can reach this by going to Admin, then View Reports. On the View Reports page, you'll see a list of all existing reports, including ones that have been previously approved. Here we find a submission report for the benchmark we added earlier. On the report page, you'll see who submitted it, a short summary of what it is and the description, the submission date, and then a link and an excerpt from the Docker Hub page where the benchmark creator should leave a longer explanation about the benchmark. You can then approve or reject the benchmark. Handling result reports is very similar. You go to the View Reports page, then read through the report and make your decision. As an admin, you may also delete results directly. For example, if they are spam and not worth being sent through the review process. Lastly, as administrator, you have access to the site editor. You can reach it by going to Admin, then Site Editor. Here you'll see a list of all currently available sites and may edit their metadata, like the human readable name or the link to the website about the server. You also have access to a smaller flavor editor, which lists all virtual machine flavors available on the site. You may add or remove flavors or edit existing ones.
In summary, EOSC Perf is the place to compare the performance of various EOSC sites in a user-friendly way. The core features available today include search for benchmarks and results, results filtering, comparison, and visualization, adding new results and benchmarks, admin features. As of today, the platform is in the testing phase. Among the planned features, we want to work on the automatic benchmark deployment via the Infrastructure Manager. Do you have any other suggestion? We are looking forward to your feedback and suggestions. Thank you for watching.